Hey everybody, so in this video I'm going to be talking about two logic gates. First, the AND gate, and then I'm going to be talking about another logic gate, which is the OR gate. So we're going to begin with the AND gate. Okay, now this is the schematic, the symbol that represents the AND gate. Now, you see here we have two inputs, and you could have many other inputs. If you're using if you want to represent this with some mathematical expression, the symbol would be the multiplication, a dot or an X. So if you pretty much see in a logic statement or an expression that says A times B or just AB, that means you're doing A and B. Okay. So given two inputs, you're going to have four different outcomes, four different possibilities. So if you have three inputs, you would have 8. If you have four inputs, you would have a total of 16. And the governing expression to that occurrence would be 2 raised to the n power, where n is the number of inputs. So if you have only two inputs in this case, you'd have 2 squared, 4 different possibilities. Okay, and those different possibilities would be, okay, so you have 0, 0, 1, 1, and then 0, 1, 0, 1. Okay, so you have the case where they're both 0, second is 1, the first is 1, and then they're both 1. Okay, and the way the truth table works, okay, so the output would be what the AND gate, the way the AND gate works is that they both have to be 1, both inputs have to be 1 in order for the output to be 1. Otherwise, they're going to just be 0. Okay, you can't just have one input that's 1 and the other input is 0. You can't. You have to have both of them at the same time be 1. And one good way to remember that is the keyword AND. Okay, you have to have input 1 and input 2 have to be 1. Okay, so no other way around it. They both have to be AND. Okay. Okay, and then moving on to the OR gate. All right, and this is the symbol that you would see, and the expression, the mathematical expression corresponding to this would be a plus. So if you see, okay, A plus B, they're just saying A or B, pretty much. Now maybe in a discrete math course or probability course, you'd see the symbol for OR being this U, and then for AND, it would be upside down U, like that. Okay. All right, so again, for the inputs, same thing. We're going to have 0, 0, 1, 1, 0, 1, 0, 1. The output is, as long as either of these two inputs is a 1, or both of them 1, then the output is going to be 1. So for 0, 0, there's not a single 1 here, so it's going to be 0. See, do we have at least 1, 1? Yeah, we do, right here. So 1, 1, and 1. All right, so that's the output. And like again, as I said for the AND gate, also for the OR gate, you could have multiple inputs. And it works the same way. Let's say we had 4 inputs. Okay, so these are like the columns for the 4 inputs. As long as you have one of the inputs being 1, your output would be 1. Same, no matter where it is. Let's say you had it right here, and the rest 0. So let's say you had multiple 1s. As long as there's at least 1, 1, your output is going to be 1. Okay, and that's pretty much it.